This is a very important part of the lesson. I want you to write down all 3 things on this checklist. Title it Checklist for Simplifying Radicals. So let's take a look at this checklist. Obviously, the radicand can have no perfect squares left. You know you're not done if it still has perfect squares in it. For example, the square root of 8, that would not be done yet. Okay, so anyways, what I was saying is that there's a perfect square left in 8, so that would not meet our checklist. Second of all, the radicand is not allowed to have fractions. So this would be disobeying the second one on the checklist if there are fractions inside the radical. Now, if there's a fraction as an answer, that's fine. Just can't be inside the radical. Finally, you are not allowed to have radicals in the denominator. So that last one would disobey the third thing on the checklist. And if you have radicals in the denominator, it means your denominator is irrational. What's the opposite of irrational? Rational. So the next few slides, we're really going to focus on this one right here. If there's a radical in the denominator, if your denominator is irrational, we're going to work on forcing it to be rational. So we're going to do something called rationalizing the denominator. Write it down. Oh, I'll come back to this. Write down rationalizing the denominator. Rationalizing the denominator. When the denominator is irrational, we're going to force it to be rational. Okay, I'll come right back. We need to have this one skill to be able to rationalize the denominator, which is something you'll use in future maths a lot. So, square root 3 times square root 3 is 3. Square root 27 times square root 27 is 27. Square root 1,289 times square root 1,289 is 1,289. It's important that we can write that right away. You don't need to write square root of 3 times square root of 3 is square root of 9 and then take the square root of 9. You don't need to do the middle step. The square roots simply cancel and you get 3. It's like saying square root of 3 squared. You know, the square and the square root cancel, and that's why you're left with just 3. Okay? All right. So, when your number has a radical in the denominator, it is wrong. You have not simplified it. So we're going to learn how to rationalize the denominator. The way you rationalize it is you multiply that number by 1. You multiply it by 1. That's how you do it. But it's not any old one. It's a very fancy number 1. Very fancy number 1. It's a very intentional number 1. So you're going to multiply that by square root 3 over square root 3. Do you agree that that's just 1? So I'm not changing it, I'm just rearranging. Okay? Why did I pick square root 3 over square root 3? Where did that come from? I just looked at my denominator. All right, let's multiply this out. 1 times square root 3. It's just square root 3. So I'm multiplying across the top. Now let's multiply across the bottom. Square root 3 times square root 3. And I totally get it. I totally know that the original one looks more simple than the answer, but that is the simplified answer. It meets every box on the checklist. All right, try these problems. I'll give you a few minutes to work on them. Make sure that your final answer meets every box on the checklist. All right, let's start working these. Number 7. I spy a blank blank. What did you see on number 7? A perfect square. Don't keep this as square root of 4 for long. Write what it really is, which is 2. So now we have 2 over square root 5. I'm obeying box number 1. I'm obeying box number 2. I'm not obeying box number 3. We broke the rules. There's a radical in the denominator. So now we need to multiply by a really fancy number 1. How did I pick which number 1 to multiply by? I looked at the denominator. All right? So I'm going to multiply across the top. 2 times square root 5 is 2 root 5. Square root 5 times square root 5 is 5. Final answer, 2 root 5 over 5. Number 8. I'm obeying rule number 1. I'm obeying rule number 2. It's that rule number 3 that we're breaking again. So we are going to multiply the numerator and the denominator by the radical in the denominator. 1 times square root 2 is just root 2. Square root 2 times square root 2 is 2. So square root 2 over 2. This one looks just like the one that we did in the example with the 3, right? Number 9. Oh man, I don't spy any perfect squares. All right, let's just go ahead and start to rationalize. So multiply the numerator and the denominator by square root 8. Square root 5 times square root 8 would be square root 40. Square root 8 times square root 8 is 8. Now I'm not done because I'm disobeying the first step of my checklist, which is not allowed to have perfect squares in the radicand. So we factor tree it, or you use your number sense and you realize, oh, that's 2 root 10. Oh, we're still not done. Here, I'll draw another arrow. We're still not done because 2 over 8, that can be reduced. 2 over 8 is 1/4. So the final beautiful answer is square root 10 over 4. Woo! 10, 11, and 12. Go ahead and try those. All right, here we go. Number 10. We are disobeying checklist number 2. Bullet point number 2 in our checklist. We haven't really disobeyed that one before. So let's go ahead and separate these. And now we've got that radical in the denominator. So now we're going to rationalize it. That means force the denominator to be rational. It is irrational and we are making it rational. Okay, we're going to multiply across the top. Square root 2 times square root 3 is square root 6. Multiply across the bottom. Square root 3 times square root 3 is just 3. The more you do of these, the quicker you're going to get. Number 11. Now, we've never had an integer in the denominator with our radical. Do not bring that along when you write your fancy number 1. Ignore the integer. So when I rationalize, I'm just going to multiply by root 6. I'm not multiplying by 2 root 6 because that's redundant and unnecessary. All right, let's make sure we can all do this correctly. Let's multiply across the top. That's the easy one. 3 times root 6, just 3 root 6. You just write them next to each other. Now across the bottom, 2 times 1, because there's a 1 sitting in front of that root 6. Just 2. Square root 6 times square root 6, that's no different. It's just 6. So that was a little bit different than the other ones. So the numerator is still 3 root 6. The denominator is 12. Boom, boom, 1/4. We love to have denominators of 4 in our final answer, don't we? I don't know. Did you get it right? Last one. I spy perfect squares. I spy 2 of them, in fact. I would rewrite this if I were you, because we are allowed to do that. That is mathematically legal. You can square root the top and square root the bottom. Totally legal. Alrighty. The numerator is completely a perfect square. The square root of 49 is 7. The square root of a to the 6th is a to the 3rd, because you just divide the exponent by 2, if you remember that from yesterday. But we still have a problem because we're disobeying that last rule. There is a radical in the denominator, and it's not simplified when there's one there. So we're going to rationalize. Dun, 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 dun. So the numerator is 7a cubed root 6. And the denominator is 6. 7a cubed root 6 over 6. Yay!